Today we're going to have a look at lowest common multiple, or as we know it in shorthand, LCM. So let's take an example of trying to find the LCM of 6 and 8. When you first start doing these sorts of problems, you do it in a long method, so you actually list the multiples of 6 and you list the multiples of 8, and then you have a look at them. Now, of course, multiples go on to infinity because we're simply counting in 6s or we're counting in 8s. So the best method to use is first of all to start off by finding the multiples of 6. And mathematicians are lazy, so we always try to find the shortest way of writing anything down. And so the notation for multiples of 6 is capital M with a 6. And that's equal to the set of numbers, which is shown with a curly bracket. And now we're going to start counting in 6s. 18, 24. And for lowest common multiple, I suggest that you go up to about the 4th multiple, and then you go from that one to the other number that you're dealing with, multiples of 8, and do the same thing there. So start counting in 8s, 8, 16, 24. Now, if you were wide awake, you would have noticed that was as far as you had to go. But let's say, for instance, that you didn't notice and you carried on to 32. As soon as you've done that, you need to look and see, is there a common number to both of those sets of numbers? And obviously there is. It's a 24. And so we have found a number that's common to both of them. And most importantly, it's the first number that we discovered, because the L in lowest common multiple is asking us to find the lowest number or the first number. So if we want to get technical, we could show that this set of numbers goes on to infinity and this set of numbers goes on to infinity. But the most important thing is that we found the lowest common multiple of 6 and 8 is equal to 24. In other words, what we found out is that the smallest number that 6 and 8 can both divide into without a remainder is 24. So let's have another look at another example. Let's, for instance, say we're going to find the LCM of 3 and 7. So we start off in the same way, multiples of 3, and we're going to start counting in 3s. And let's do the first 4. So 3, 6, 9, 12. Okay, we might come back to that, but in the meantime, let's do the multiples of 7. And we're going to open our curly brackets, start counting in 7s. 7, 14, 21, 28. All right, and if we have a look at that, we haven't found a multiple of 3 and 7 that is common yet. So then we go back to the 3s and we say, okay, let me do another 3 or 4 of them. So 3, 6, 9, 12, 15, 18, 21. And again, if we're wide awake, we're not going to have to go any further, because we've seen now that multiples of 3 have got the number 21 and multiples of 7 have got the number 21. And that was the first number that we came across that was common to both of them. Again, if we want to be technical, we can show that they go on to infinity, which means they go on forever. But we have found the LCM of 3 and 7 is equal to 21. In other words, the smallest number that 3 can divide into exactly and 7 can divide into exactly is 21. Now that's all well and good, but as you get on further in your schooling, you're going to need to be able to find out the LCM of 2 numbers or even 3 numbers in your head as quickly as possible, especially when you get onto fractions and finding the common denominator when you're adding or subtracting, which will be in another video. So let's do an example now with the short way. Let's say we're going to find the LCM of 5 and 6. Then what we do is we don't write out the multiples, we just start a mental process of checking what will go into what. So what you do first of all is you look at your two numbers and you decide which is the bigger number. And if you want to, you can write it down so that you keep a running tab of what you're doing. Some people just do it in their heads, that's fine, but if you want to write it down, you can. So we write down the bigger number, and then we say, can the smaller number divide into the bigger number exactly without a remainder? And the answer is no. So then we go on to the next multiple of 6, which is 12. Can 5 divide into 12 exactly? No. So we go on to the next multiple, which is 18. Can 5 divide into 18 exactly? No. Next multiple of 6 is 24. Can 5 divide into 6 exactly? No. So again, we go on to the next multiple, 30. Can 5 divide into 30 exactly? The answer is yes. And as soon as you get an answer of yes, that means that you found your answer. And so the LCM of 5 and 6 is 30. Let's have a look at finding the LCM of 3 numbers. Let's find the LCM of 3, 8, and 12. So we're going to start in the same way, but because we've got 3 numbers, we're looking for the biggest number of the 3, which is 12. Okay, so we say, can 3 divide exactly into 12? And the answer is yes, so this looks hopeful. Then we have to check the other number as well. Can 8 divide exactly into 12? The answer is no. As soon as you get a no, you know that that one won't work, and you need to go on to the next multiple of 12, which is 24. Go back to your questions. Can 3 divide exactly into 24? Yes. Can 8 divide exactly into 24? Yes. And so therefore, my LCM of all 3 of those numbers, 3, 8, and 12, is 24. And if we think about it, 3 goes into 24 8 times, 8 goes into 24 3 times, and 12 goes into 24 twice. There's one last thing that could happen. Let's say we're trying to find the LCM of 8, 4, and 16. Alright, again we've got 3 numbers, so we look at the biggest of the 3 numbers, and the biggest of the 3 numbers is 16. So we start asking the questions. Can 8 divide exactly into 16? Yes, it can. It can go in twice. Can 4 divide exactly into 16? Yes, it can. It can go 4 times. And obviously 16 divides into itself. So in this case, we didn't have to go further than the largest number. The LCM is actually equal to the largest number that we were given. And that can also happen. So if we wrap this all up, especially with the shortcut, I want to concentrate on the shortcut because it is so necessary for the higher grades, the higher you go up, before you're allowed to use a calculator. So we can have a situation where we need to find lots of multiples before we find the actual LCM, or we need to just look at a few multiples and we've got the LCM. And the third thing that can happen is we actually have the LCM amongst the 3 numbers. I hope that's been helpful to you, and I hope to see you in future videos.